All right, the next problem that we're going to do involves the product rule, and it involves evaluating a derivative at a specific point. So this is product rule evaluated at a specific point. At least that's my descriptor for it. Okay, so let's go ahead and write down the problem and get started. So we're being asked to evaluate j prime of 0. Okay, and j rather is given as 1 minus x squared times negative 3x squared plus 2x. Okay, so we need to find j prime and then evaluate it. And it's product rule, so it's again the rule itself, which we should write down. It states that if j is f of x times g of x, then j prime is given by f prime of x, g of x, plus g prime of x, f of x. All right, so then we're going to go ahead and, of course, label this as our g, and then this other function, actually, my bad, that is going to be f. This is going to be f. And then this is going to be g, right? So in other words, we need to take f prime. So I'll put it in parentheses and put a prime there, and then leave this one alone. And then I need to take g prime. So this function, I take the derivative of it and leave f alone, which is 1 minus x squared. Okay, so these are polynomials, quadratics, and so the rule is fairly easy to apply. So this is going to be minus 2x, and we leave this alone. And then we want to take the derivative of this piece over here. So this is going to be minus 6x plus 2. And then we just take a quick look just to make sure that everything looks correct. And I think we're on the right track. So then now what I need to do is distribute that over this way. And then of course, over here, we've got to distribute as well, but we like to use the FOIL method, right? That's fairly commonly used to help us keep track of how we're going to distribute. So then this is 6x cubed minus 4x squared. And that takes care of that distributive property onto the binomial. We'll put this one in parentheses, although it's not as important because we do have a plus sign here, but it still makes more sense to me to do that. So first, outer is 6x cubed, inner is plus 2, and last is minus 2x squared. All right, so this is the still working on the derivative. All right, so we're getting real close to where we can well, we should really simplify here, although I think before we can combine like terms, we may have one more step here, which is to get rid of the parentheses. So we've got minus 6x plus 6x cubed plus 2 minus 2x squared. Okay, and then I'm just going to take a quick step back just to see that I haven't lost anything. For example, I almost lost an exponent there. And I think it looks fine. So now combine like terms, and then we'll be able to evaluate. It's J prime. We're still working on J prime. So let's go ahead and try to combine like terms. So this is cubed, as is this, right? So that's going to give me 12x cubed. This is squared, as is this. So then that results in minus 6x squared. There's no other linear term, so we'll just write the minus 6x, and then the constant 2, that's the only constant. All right, so now to wrap this up, I'm going to do that over here because we want to go back and remember that we wanted J prime of 0. So J prime of 0 means that I have to plug in 0 everywhere, that there's an X. So all these terms here cancel out. And so J prime of 0 is 2. And that's, whoops, that's what we were asked to deliver. That's what we were asked to find. So our answer is J prime of 0 is 2.